Hi, this is the beginning of your 2 days of notes on integration, and these are the last 2 days of notes for the course, and then we're done with all the new material. So kudos to all of you for doing this and finishing so strong. Integration is probably the easiest thing that we're going to do in this class, so we're going to end on a nice easy note, but don't forget that you do have a test on Thursday on both derivatives and integration. The derivatives will include your product rule, your quotient rule, your chain rule. For derivatives, it'll include you finding the slope of a line. Given an x value, finding the slope of the tangent line given an x value to any curve, and being able to write the equation of the line tangent to any curve at a value of x. I will be running 2 Zoom review classes for you guys on Wednesday. I don't know what time yet because I'm going to be taking care of my grandchildren also, and they also have Zoom classes. So I'm going to have to see what their schedule is and then fit in our Zoom classes in between theirs with their teachers. I'll give you more information as soon as I have more information. But you can join either one or both of the Zoom classes on Wednesday to review before you take your derivatives and integration test on Thursday. Then Thursday there is your first review assignment, and even though we don't have a final exam, we're still going to review the course till the end of the year, and you have 3 more online tests. Don't forget that your tests count as 50% of your grade this marking period, as they did every marking period. And remember that your 4th marking period does weight heavier towards your final average because we don't have that final exam to average into. So I'm going to take your 4 marking period averages, divide by 4. That will be your numerical grade. That will translate to a letter grade for the college, and will also translate to whatever grading we're going to have at the high school, which I'm not really exactly sure yet. Okay, so let's get through these notes on integration day 1. And as you can see from the top of the notes, it says integration day 1, and it says it's also called the antiderivative. And basically you do just the opposite of taking a derivative. So we're going to start with indefinite integrals today. Tomorrow we're going to do definite integrals. Your integration symbol kind of looks like an S, sort of like an elongated S. And that's because when you take calculus next year and you do something called Riemann sum, and you're going to find the area under a curve, find the area outside of the curve, average them together, that's what your derivative is going to give you. Don't have to worry about that today though. All right, so you would have some function written inside the parentheses and then a dx. Okay, so say the function is a times x raised to the b power. The coefficient is a, the exponent is b. If you are doing a derivative, you multiply b times a, that becomes your new coefficient, and then you subtract 1 from the exponent. But when you do integration, you do exactly the opposite. So when you integrate this, you drop out the integration symbol, you drop out the dx, you keep the same coefficient, you bring your exponent up by 1, so the exponent will become b plus 1, and then you divide by that new exponent, b plus 1. And then you also have to add on, for an indefinite integral, a possible constant of c. So plus c will be in your answer for indefinite integrals. And I'll explain that when we do the next one. Okay, so let's go through these examples. I don't think you'll have any trouble at all understanding today's notes. Example number 1 is the integral of 5x plus 6 and then dx. So the function that we're integrating is the linear function 5x plus 6. This integration symbol and the dx is just a setup, and when you do integrate, you drop both of those out. Okay, so this is an exponent of, I'm going to actually add 1 line in here. So this would be the function 5x raised to the first, and this is plus 6x raised to the 0. Remember that anything to the 0 power is 1. So this x to the 0, which is 1 times 6, is the same as this 6, but we need that variable in there to do the integration. Okay, so now I'm going to integrate. I'm going to drop out the integration symbol and dx. So I'm going to keep my 5x. I'm going to add 1 onto the exponent, so it'll become 5x squared, and divide by that new exponent of 2. And this will be plus 6. Bring your exponent up by 1 to the first, divide by that new exponent of 1, and then plus c. and then just clean it up. So the integration will be 5/2 x squared plus 6x plus c. So this is the indefinite integral of that function. Now, you can always check your integration to see if you've done it right by taking the derivative. So here's my check. And I won't do it for all of them, but I'm going to just show you how you can check that. If you were to take the derivative of this function, of this integral that we got, and you multiply 2 times 5/2, you would get 5x. You bring your exponent down by 1. The derivative of 6x to the first, 1 times 6 is 6, and that becomes an x to the 0. And the derivative of a constant is 0. So when you're doing an indefinite integral, you have to keep the plus c in as part of your answer, because the function could have had some constant number there that when you took the derivative it became a 0. Okay, I'm going to go a little bit quicker through the rest of these examples. There's one special case that you have to be careful of and be aware of. And that'll come up after we do the next example. So here's example 2. And example 2 is we're going to integrate the function 10x to the 4th plus 2x cubed minus 4x dx. Again, the integral symbol and the dx is just a setup. Those are going to drop out when we do the integration. And we're doing an indefinite integral, so what we're going to do is we're going to raise this exponent by 1. So become 10x raised to the 5th, divide by the new exponent of 5, plus 2x, bring your exponent up by 1 to the 4th, divide by your new exponent of 4, minus 4x. This has an exponent of 1, so we're going to bring it up by 1, exponent of 2, divide by your new exponent of 2, plus a possible constant in our original function, and then just clean it up. So our indefinite integral will be 2x raised to the 5th plus 1/2 x raised to the 4th minus 2x squared plus c. There you go. Okay. Now, the situation you have to be careful of, the one special case where something can happen that is a little weird, is if you have the integral of 1/x dx. Now, as you continue on in calculus next year, there's going to be more integration rules that you're going to have to memorize. This is the only one you really have to know for this class. If I rewrote this so it wasn't a fraction, it would be the integral of, you know, that's an x to the positive 1 down there. I could rewrite it as x raised to the negative 1. Same function, I haven't done the integration yet. But when you integrate this, if you add 1 onto your exponent, you would get x raised to the 0, and if you divide by 0, that's undefined. So this situation is always equal to ln, which is the natural log of the absolute value of x, and then you have to have plus c because there could have been a possible constant. So this is just something that you're going to have to memorize next year. That'll become more important as you continue on with Calc 1. All right, so let's do 2 more situations, 2 more examples for indefinite integrals. Example number 3 is the integral of 6x raised to the 5th plus 4x squared minus 6. Now, if it helps, you could write that as an x to the 0. It's just the constant 6 plus 2 times x raised to the negative 1 power. Here's our special situation right there that we're going to have to use. And then minus 4x raised to the negative 3, and then dx. So what we're integrating is what's inside the parentheses. Okay, so do each one. you're going to bring your exponent up by 1 and divide by the new exponent. So the integration of 6x to the 5th, you keep the 6, x, you add 1 onto your exponent, 6x to the 6th divided by 6, plus 4x, bring your exponent up by 1, 3 divided by 3, minus 6. Now this is an x to the 0, so it's going to become an x to the 1st divided by 1, plus 2. Now here's our situation, because if you add 1 onto this exponent, it becomes a 0, and then you divide by 0, it's undefined. So that's your rule that you have to memorize. So it's 2 times the natural log of the absolute value of x, and then minus 4x, add 1 onto your exponent, that becomes a negative 2, divided by the new exponent, negative 2. And then don't forget, because it's an indefinite integral, you have to have a plus c at the end of it. It's part of your answer, because the original function could have had a constant. And don't forget, when you take the derivative of a constant, it becomes 0. Okay, now I'm just going to clean this all up, and we'll have our indefinite integral. The 6's cancel, so it's x raised to the 6th plus 4 thirds x cubed minus 6x plus 2 times the natural log of the absolute value of x. Negative divided by a negative, this becomes a positive. 2x raised to the negative 2 plus c. And then the only thing that we still have to worry about is this negative exponent in there. So I'm going to do one more step to get rid of the negative exponent. So the answer would be x raised to the 6th plus 4 thirds x cubed minus 6x plus 2 times the natural log of the absolute value of x plus 2 over that x is going to come down in the denominator, and the exponent will become positive, and then plus c. And then we have to include that in this integral, x cannot equal 0 because of the 0 in the denominator. Okay, last example. So for example number 4, we're going to find the integral of, and then I have 2x plus 3 times x squared plus x minus 6 dx. So this function inside here is what we're integrating. There's no like product rule and quotient rule that you have to worry about for this class for integration like you did for derivatives. So what you need to do is you have to actually take this 2x plus 3, distribute it to all of this, combine like terms. That'll take maybe 2 steps of algebra. So we're finding the integration of, first I'm going to multiply 2x times everything in here. So I will get 2x cubed plus 2x squared minus 12x. Make sure I didn't make a mistake. Now I'm going to distribute the 3 to everything in here, plus 3x squared plus 3x minus 18. This is still our function that we're integrating, so I need my integral symbol and dx. I'm just going to combine like terms for this function, so we're going to integrate. This is the only x cubed term, so we have 2x cubes. This 2x squared and that 3x squared gives us 5x squareds. Negative 12x plus 3x is minus 9x, minus 18 dx. Okay, so we've multiplied those together. We have our function that we're integrating. Bring your exponent up by 1, divide by the new exponent, drop off the integration symbol and the dx. So 2x, bring your exponent up by 1, raised to the 4th, divided by 4, plus 5x cubed divided by 3, minus 9x. Remember that's an x to the 1st, squared, divided by 2, minus 18. Now, this is 18x, negative 18, x raised to the 0 power. So when I bring that exponent up by 1, it'll be negative 18x raised to the first divided by 1 plus c, because our original function could have a constant. And then we just have to finish by simplifying everything. So the indefinite integral is 1/2 x raised to the 4th plus 5/3 x cubed minus 9/2 x squared minus 18x plus c. Okay, now I'm not going to write out this on the back, but hopefully you open up the copy of my filled in notes and you're looking at this. So I'm going to just kind of explain it to you. What we're going to do tomorrow was called a definite integral. If you have any curve and you want to find the area between the curve and the x-axis and any two values of x, you would use definite integrals, and again, that's what we're doing tomorrow. But this is called Riemann's sum. This is an example of it that you're going to learn next year in Calc 1 that's really not necessary for you to know right now. But if I look at the function y equals x, which is just that diagonal line, and I want to find the area of that function between x values of 0 and 10, well, this is a very easy example. Certainly it's just a triangle and you could find the area of that triangle very easily. But what Riemann's sum is and what you're going to use integration for next year when you do calculus is if you break this area into small rectangles that are a little bit below the function and you find the area of all of those, and then you do rectangles that are a little bit above the function and you find the area of all of those rectangles, to find the exact area between that function, the x-axis, and x values of 0 and 10, you would add up all of these areas that are a little bit below the function. You would add up all of these areas that are a little bit above the function, and when you average those, you would get the exact area. So that's what we're going to tomorrow. Hopefully this was pretty straightforward and easy for you to understand. I hope you guys have a great day. See you tomorrow.